In this lesson we're going to look at laws of logs. We're going to look at how to add them together, subtract them, and another rule at the end, rule 3, to do with powers. So the first rule that we're going to discuss here is if you add two logarithmic values together, then the answer to this is log of x times y. Now you'll notice that the base is all the same here. We've got a base A, and a base A. This needs to be the case to add logarithms. So log x to the base A plus log y to the base A is equal to log xy to the base A. So let's look at how that works. If we have got log 8 to the base 2 and we want to add log 4 to the base 2, then we really just do 4 times 8, so we get log 32 to the base 2. Now why does this work? Well, logarithms are powers, and when you multiply powers together, the laws of indices say that you add the indices together, the 3 and the 4, to get 7. So another way to look at this is, let's get the answers to these. So 2 to the power of what is 8? That's 3. The answer to log 4 to the base 2, 2 to the power of what is 4? That's going to be 2. And if we add these powers, 3 plus 2, we should be getting a 5 here. 2 to the power of 5 is 32. Well, 2 times 2 times 2 is 8, times 2 is 16, times 2 is 32. Yes, it does. So this actually works out when you get the answers to it. Now this means that when you subtract logs in rule 2, you do the opposite, you divide instead of multiply. Notice the bases are all the same again. So how does this work? Well, when you have log 16 to the base 2 and you subtract log 8 to the base 2, you divide the numbers in red. So you get log 2 to the base 2. And again, if we're thinking about indices work, when you divide indices, you subtract the powers. So let's work this out and see if it works out here. So 2 to the power of what is 16? That is 4. 2 to the power of what is 8? Well, that's 3. If I do 4 take away 3, this should come out to be 1. And that's the case. 2 to the power of 1 is 2. Okay, the last rule of logarithms is this rule here. Log to the x to the power n to the base a is also equal to n log x to the base a. Now this looks like some sort of differentiation. You take the power down to the front. It's not at all, and I'll explain how it works. So here, if we put numbers in, it's sometimes easier to see what's happening. If we get log 9 squared to the base 3, we can rewrite that as log of 9 times 9 to the base 3. Now, using rule 1, when you're multiplying that out, you could have log 3 to the base 9 plus log 9 to the base 3 plus log 9 to the base 3, because when you add logs together, you multiply the two red numbers. That's like a reverse of rule 1. How many logs have we got here? We've got 2 log 9s to the base 3. So effectively what's happened there is the 2's went to the front. Now why does this always work? Well, if I put a 3 up there, then I'd have 9 times 9 times 9 here. And that would mean log 9 to the base 3 plus log 9 to the base 3 plus another log 9 to the base 3, which should give you 3 of them. So if the power was 3 here, I'd have a 3 at the front. If I put the power to 4, I'd have 9 times 9 times 9 times 9, and then I'd have 4 log 9 to the base 3's, which would put a 4 at the front. So this always works. And it's transferable too. If you've got a number at the front, you can take it up as a power. If you've got a power, you can take it down to the front. And that's all the rules, the main rules of logs that you need to know. In the next lesson, we'll put them into practice.